This video is designed to discuss basic formula transformation and to give you an idea of how and why that happens. I'll have other videos for more complicated situations or specific situations. Here's a common formula: distance equals rate times time. Sometimes you might want to have this formula solved into a format that allows you to know what the rate is each time, so that you could, if you did a series of experiments, put in the distance traveled and the time spent traveling and get out your average speed each time. Instead of remanipulating or solving the formula each time, you might want to just have it set up so that you know what R equals. So you are allowed to divide each side by a variable just as you are allowed to multiply or divide each side by a constant, or a number. So we can divide each side by t, and what that's going to give us is R equals distance over time. Now, of course, rate is a speed, often known as a speed. So this is a rate or speed, and these are often considered the same thing. They're just different words for it. And that makes sense because if you think about the units involved with this, distance might be in, let's say, miles, and time might be in hours. And therefore, if you did distance divided by time, you would get something that would be in miles per hour, which of course is a speed. That makes perfect sense. When you solve for a variable like a variable formula like this, you do have to be careful to note restrictions. What I mean by that is this rate with distance divided by time doesn't actually make sense if the time is 0. So typically, if you solved something like this, you would write distance over time, rate equals distance over time, and you would then note a restriction: time cannot be 0. So that makes perfect sense, because if you spent 0 time traveling, you should have covered 0 distance, and it's nonsense to figure out what the rate is. In other words, you can't divide by 0. In this next slide, we have another common formula. This one's for finding the perimeter of a rectangle, where L is the length and W is the width. So if you wanted to solve, for example, for the length, putting in the width and the perimeter a number of times, if you wanted to do a series of problems like that, you might want to have this solved for L, so it's much easier to just plug in P and plug in W. So if we're going to do that, what we need to do is look at how to get L by itself. So there's a couple of ways we're going to look at on doing this. The first one is going to be to simply divide each side by 2 right off the bat. And if we do that, we're going to get P over 2 equals, and now the parentheses no longer are necessary because there's not 2 of them, there's just L plus W. And now, of course, what we can do is subtract W from both sides, and we're going to get P over 2, or 1/2 P, depending on how you want to write it, minus W equals L. So that would be one approach for solving this formula for L. Another approach might be to distribute first, so let's take a look at what that looks like. If we distribute, we're going to get P equals 2L plus 2W, and then we're going to be able to subtract 2W from each side. Remember, we're solving for L, so subtract 2W from each side. That isolates the variable term, and now we're going to divide each side by 2. And what we're going to get is P minus 2W over 2 equals L. Now, this looks suspicious because these two solutions don't look the same, but we should get the same thing. But of course, if you separate this one over here, if you separate it into 2 separate terms, which you can do, you could write it as P over 2 minus 2W over 2, and once you've done that, you can simply reduce the fraction 2W over 2 by canceling the 2's and getting P over 2 minus W, which means you get exactly the same thing as what you have over here, and therefore those two things are the same. Now, this is a fairly common occurrence where people will solve with a different path the formula, and then you might wonder, have we both done it correctly? Do we have the same thing? And so you need to also be comfortable taking a formula or some version of a formula and verifying or that it's the same as someone else's formula, or in fact verifying that it's different. Here's one final formula that's fairly straightforward to solve, and also a very common formula. This one is actually what someone who, for example, came from Europe and was used to temperatures in centigrade would do to convert a Fahrenheit temperature, to wonder why they're standing there in their shorts and shivering. So for example, this one basically says if you input a Fahrenheit formula and go through the formula, you're going to get the centigrade formula. But what if you were an American in Europe and you were given a centigrade formula and you wanted to know what the Fahrenheit equivalent was? Well, that would be solving this formula for F. So in order to do that, what I would do is multiply both sides by 9/5, which is dividing by 5/9. So I'm going to say times 9/5 times 9/5. And if we do this, we're going to get 9/5 C, which also could be written as 1.8 C. So 9/5, of course, is 1.8 if written as a decimal, equals F minus 32. And then you simply add 32 to both sides. And you're going to get the conversion that someone in the US would use if they were standing in Europe going, why is it cold? Or why is it too hot? Because the temperature says some degrees centigrade, and you don't know what that is in Fahrenheit. So if you're watching the news and it gives you the temperature, you got to go, okay, I need a jacket or I should be wearing shorts. So this would be the equivalent conversion, and you would put the centigrade temperature in, multiply it by 1.8, add 32, and you would have the Fahrenheit temperature. I hope that's been useful.